Imagine a world where your PC isn't powered by silicon, but by biological cells. Sounds like science fiction? Well, researchers are actually trying to figure this out right now. We're pushing the limits of silicon, so what's next? Could biological processors be the future of computing? Let's dive in. Stick around. Alright, so first things first, what exactly are we talking about when we say biological processor? Instead of transistors etched onto silicon wafers, we're talking about using actual living cells or components of those cells to perform computations. Think DNA, proteins, enzymes, the building blocks of life as we know it. Biology, at its core, is all about processing information. Cells are constantly receiving input, processing it, and then reacting accordingly. They're like tiny, self-contained computers already. What researchers are trying to do is harness that natural processing power and use it for more complex computations. The way these biological processors would work is fundamentally different from traditional silicon-based processors. Instead of relying on electrical signals to represent data, they would use chemical or biological processes. Biological systems are incredibly efficient. Our brains, for example, can perform incredibly complex calculations using a fraction of the energy of even our most powerful supercomputers, and they can do it while also running all the other functions that keep us alive. So the potential here is huge, but how would we actually build one of these things? Let's get into it. Let's dive into the nitty-gritty of how these biological processors would actually function. Imagine DNA as the programming language dictating the instructions for the processor. Proteins and enzymes act like the hardware, carrying out those instructions. Input signals, maybe in the form of chemical concentrations, are introduced to the biological system. These signals interact with specifically engineered DNA sequences, triggering a cascade of biochemical reactions. These reactions, guided by the DNA's instructions, produce specific outputs, essentially giving you the results of your computation. It's like a complex microscopic assembly line, all orchestrated by the code written into the DNA itself. One of the most fascinating aspects of biological processors is their potential for self-repair. Imagine a computer that could fix its own glitches. That's a game changer. Okay, so we've covered the basics of what biological processors are and how they might work. But what are the potential advantages and disadvantages of this radical new technology? Biological systems are incredibly energy efficient. They could be orders of magnitude more efficient than silicon-based systems. Another advantage is self-repair and self-replication. Imagine a computer that heals itself or creates copies. But there are challenges, like complexity and speed. Ethical considerations are also significant. So, how close are we to actually having biological processors powering our devices? The short answer is, we're still in the early stages. But that doesn't mean there hasn't been progress. Researchers around the world are making exciting strides in the field of biocomputing. We're seeing breakthroughs in DNA computing, where DNA strands are used to perform calculations, and in synthetic biology, where scientists are engineering new biological systems with enhanced computational capabilities. For example, researchers have successfully built logic gates, the fundamental building blocks of computers, using DNA and enzymes. Others have created biological systems capable of storing and retrieving information, essentially acting like biological hard drives. Scientists have even created biological transistors called transcriptors, which could pave the way for more complex biological circuits. While these breakthroughs are incredibly promising, we're still a long way from having a fully functional biological computer, but the pace of research is accelerating. Now the big question, could we actually see a PC running on a biological processor in the future? It's a question that has both technical and practical implications. On the technical side, there are immense challenges to overcome. We need to figure out how to scale up these biological systems, making them large and complex enough to handle the demands of modern computing. Right now, we're talking about tiny systems that can perform basic calculations. To run your favorite software, we're talking about a whole other level of complexity. Then there's the issue of interfacing biological processors with existing technology. How do you connect a biological system to a motherboard, a monitor, or a keyboard? These are all engineering challenges that would need to be addressed. Practically speaking, there are also questions of cost, reliability, and even public perception. But let's say we could overcome these hurdles. What would a biological PC even look like? It's fascinating to think about. While a fully biological PC might be a long way off, there's another intriguing possibility: hybrid computing systems that combine the best of both worlds, the speed and reliability of silicon with the efficiency and adaptability of biology. Imagine a system where a traditional silicon-based processor handles the heavy lifting, while a biological processor tackles specific tasks that play to its strengths, like pattern recognition or complex simulations. This kind of hybrid approach could lead to significant performance and efficiency gains. Think about artificial intelligence, for example. Biological systems excel at learning and adapting. A hybrid system could leverage these strengths to create more powerful and efficient AI algorithms. We could see AI that learns more like humans do, but with the computational power of our most advanced machines. Hybrid computing represents a fascinating middle ground, a way to bridge the gap between silicon and biology and unlock new possibilities in computing. So, we've explored the science, the potential, and the challenges of biological processors. Now, the question is, would you actually use a PC powered by biological cells? Imagine a computer that's more energy efficient, potentially self-repairing, and capable of things we can only dream of with silicon. But it might also come with its own set of quirks and limitations. Would you be willing to make the switch? Let me know in the comments down below what you think about biological processors. Is this the future of computing, or is it just a sci-fi fantasy? Let's discuss. That's it for this one, everybody. We've covered a lot of ground, from the basics of biological processors to the potential of hybrid computing systems. If you're as fascinated by the future of computing as I am, hit that like button and subscribe to the channel for more deep dives into the world of tech. And don't forget to hit that notification bell so you don't miss out on future uploads. As always, thanks for watching, and I'll catch you in the next one.